Okay, what I'm going to try to explain right now is the difference between output and input. This part that I'm going to take up first, we've already talked about in the computer hardware unit, and then I'm going to move on to outputs and inputs, how they relate to the actual Arduino. So we know that some of the outputs that we talked about in the hardware unit are the things that the computer sends out information to. So things like our monitors, speakers, printer, etc. So again, anything that goes from the computer to the external device. The next thing is receiving information by the computer. So how do we input information to the computer? We use things like a mouse, keyboard, microphone, camera, etc. So that's kind of the difference between output and input when it comes to computer hardware. Now moving on to the new topic, which we're going to get into in this hands-on unit with the Arduino, is the difference between digital output and input. So again, when we're talking about digital, we're talking about signals that are only going to be either on or off. Most of the circuits, or all of the circuits that we did in the logic unit, where we're breadboarding with logic, we were able to do signals as either high or low, on or off, and we'll also receive that output as high or low, on or off. So our output was our LEDs, they would either be turned on or turned off. Our inputs were our wires, and those wires would either be hooked up to power for being on or off to ground. So in this case, we're going to talk about actual devices that we can wire up to the Arduino and figure out whether that's output or input. One of the first circuits that we're going to build is with LEDs. So what we're able to do is turn on those LEDs and on and off, just like we did in the logic unit, and we'll control that with code with the Arduino, as you'll see when I upload the video about using the Arduino in Tinkercad. Some of the other things that we are going to control outside of our Arduino is we'll be sending signals to control motors, servos, etc. Okay. The output in terms of digital, we can turn them on or off. So I'm actually going to take servos off the list because that won't really be used in terms of on and off. But two of the examples that we will use are LEDs and motors. So we'll be sending those signals through digital. How I can send signals to the Arduino. One of the first ones that we're going to do where we're sending signals into it or sending values into it would be a button. And again, a button is either pressed or not pressed, so that's why it's a digital device, on or off, as you'll see when you get through to those circuits. Something else like a switch, again, it has a state either on or off. And the one thing that I talked about I would talk about in class is the difference between a regular on-off switch and then what we're going to do to move into the analog inputs. And at your house, and again, we may not use specifically this example with the Arduino, but if we're going to list the dimmer switch that you have in your house where you can actually dim the light to different levels, that would be where we would list it there. We are going to use one that's similar to a dimmer switch. It's actually a variable resistor, and it's called a potentiometer. And so that'll be like a dial that we use. If you think about radio dials in your car, you would be able to turn it up and down, so it has different levels. That means it's analog, so that's kind of the same as a rotary dimmer. And again, if you have those style of slide or dimmer switches at your house, you understand the difference between a simple on and off switch and then that dimmer switch. In this case, it rotates because it's kind of a dial. Okay. One of the other inputs that we will use in that unit will be a temperature sensor. And again, if I'm reading temperature, it's not just yes or no, on or off. It's actually going to send a bunch of different levels. So again, that would be sent to the Arduino. That's why it's an input, but it would be in fact analog. We can also use a light sensor, and we refer to this as a light dependent resistor or a photoresistor. and that will be used in one of the circuits as well where we're reading in light levels. The example I give with that for reading in light levels, if you have automatic headlights on your car, if the light level drops below a certain value, what's read in on your dashboard, if you go through a tunnel or it gets dark at night, then that sends a signal to your headlights to automatically turn on. The other thing that we can read in light sensors for, the other example would be if you have any type of solar lights that turn on at night. So during the day those would charge, and then once the light level gets below a certain point, then it could tell the lights to turn on. So those are some examples that we'll use for analog input. So the other thing that we can do is control our output devices through analog as well. So if I now all of a sudden call it a dimmable LED, so instead of just turning the LED on and off like I did in the digital section, I can actually dim that LED. So the first circuit you'll have, part of that circuit will just turn on and off LEDs or blink an LED, but then there'll be an extension where you actually need to use a breathing LED or a dimming LED. So that'll be one of the things that you look at there, and that's the difference between analog and digital in that sense. If we can do various speeds with a motor, and the example I would give with that is if you were using a DC motor, let's say you had an electric vehicle and you're using DC motors to drive that vehicle, because we're not using combustion engines or a drivetrain, it would be DC motors in each wheel. You wouldn't want those just to be simply on and off. So essentially, if you thought about a Tesla and you were driving your Tesla, if you hit the gas pedal and the motor would be on full, or if you let off that gas pedal, it's turned off completely, you would have a very uncomfortable ride, because things would either be very jittery, you would accelerate extremely fast, and then you would stop at a dead stop. So that would be very uncomfortable. So instead what it does is we're able to control those DC motors with analog. So I can set different levels, I can get it to smoothly accelerate and change that way. So those are the type of outputs that we'll be using in this unit that are in fact analog. So hopefully that gives you a basic overview of what the difference is between output and input. As you go through the circuits this week and the next few weeks, you will get a chance to explore a lot of these.